Everybody agree with that?
Yes.
That's not right.
No.
Can anybody come fix it?
It needs to be one on the bottom, right?
Does everybody agree with this? No, that's not right. Silicon, this was a good attempt, but it's wrong. This is what silicon looks like as an atom. Lewis dot structure. And then as an ion, you're going to use these brackets because it is going to lose 4 electrons. And it's going to behave like the noble gas argon. No, silicon actually behaves like neon, the noble gas neon. Okay, so when we're dealing with the loss of electrons, they're actually not going to be shown as an ion around it. This is going to behave like the noble gas configuration neon. Now this one's going to behave like which one? This is behaving like neon. What's this? This is gaining 4. This is losing 4.
That's going to behave like
Argon.
Oh, yeah.
This is neon. This is argon. So silicon has several oxidation states. You can go on Wikipedia and you can find them here. You can see silicon's 4 negative, 3 negative, 2 negative, 1 negative, 1 positive, 2 positive, 3 positive, 4 positive. So it has 8 different oxidation states silicon does. So there are 2 ways of showing this. We want to obviously make sure we're showing it the correct way. This is the correct way for the loss. This is the correct way for the gain. All right, so who wants to do phosphorus for? Okay, nice job, Cody. All right, so if we look, what's it going to be as an ion? So as an ion, you're going to say and it is going to gain 3 electrons, right? All right, so write that down for phosphorus. This is what phosphorus will look like. And let's take a look at the last one, strontium. All right, so make sure that when you do it as an ion, it's losing 2 electrons.
Oh,
so you're not going to actually show them there.
Oh, wait, what?
Yeah, when they lose electrons, remember, you're not going to show them there.
Okay.
Because this is showing you that it's behaving like the element beneath it, that is the noble gas. So when strontium loses 2 electrons, it's going to behave like krypton. Because 38 minus 2 is what? 36. Very good, Hannah. 38 minus 2 is 36. So it's going to behave like krypton. The aliens activity coming from the National Association of Chemistry, which would be right here. The American Association of Chemistry Teachers, alien activity. So the aliens are in the right group, they're just not in the right period. Is everybody clear? So on this activity, Cody, on this activity I've placed the aliens in the right group. They're just in the wrong period. So this one right here, the one in the middle, that is 3 on your paper. If you look at number 3, on the 8, 3, 8, right? 3, 8. That should actually be the first group. So I wrote 1-8 here. The one beneath it should be in the second group. And the one beneath that should be in the third group. And then the one on 2 should be in the fourth. And the one on the top should be in the fifth. So can anybody notice the pattern? Today we're looking at observing patterns with the periodic table. What pattern am I following to put them in the right group there? Anybody? Raise your hand if you get it. Clayton. Losing points. be focusing on this up here. We're trying to observe some pattern. So what is the pattern that we're trying to observe here? Anybody? Has anybody noticed it yet? 10 points? All right.
Is it like? Is it just order?
No, on this one right here, well, I've given you the first answer, right? This block, I've told you the answer. What pattern am I following to get this is the first, this is the second, this is the third?
It's correct.
What am I numbering them by? Look at the actual stick figure thing. One of them should be increasing. What is increasing in the figures? All right, Michaela. Right, the legs. You can do the legs or fingers, but this one has 2 legs. This one has 3, 4, 5. And the last one has the most. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. This one actually should be 5, and this one should be 4. So they're differing by the number of legs. Very good, Michaela. Points for you.
Lauren, how are you behind me in coloring? And I started coloring after all of you.
That's why I should take my time.
I colored my people a different color than my
Well, okay, I can see you doing
You can have no idea what's going on, so I would not have recommended. I would have recommended doing one group at a time.
Unless you have no sheet I can look at. Just like
You can go up there and take a look at that one at the top.
I'm the guy to get it.
You get it? Yes.
Really, you just now
Wait, so you
getting
did
here?
the you did number
Hold on,
8 already.
Violet, we can't.
But then why do all that?
What'd you name your little?
Huh?
What's that thing called? Did you name it yet? It's a good stress ball. That is a really nice, good stress ball. Yes, it's recording. I was just looking at your stress ball. Where are you going? No. Oh, it looks so good, Minnie. Wonderful. Very good. Nice observing the patterns there. Excellent job there. Excellent. Piece of glue. There's a box of sticks up there. It's empty. Just be patient. Okay, you're close. That's not correct. That's silicon as an atom. That is correct as an atom. But we're looking for it as silicon as an ion, 4 positive charge. No. When you do the ion, you're going to go Si brackets 4 positive. That would be the charge, 4 positive. Now sometimes people write it like this, positive 4. I prefer to write it like this, 4 positive, because it's telling you the charge.
I thought it was a dot.
If you see, it is Lewis dot. That is Lewis dot. Now this is behaving like it's lost 4 electrons. You can also write it like this. Now in this case, it would have gained 4 electrons. So silicon can do both. Diane, you might want to write this down. Lily, you might want to write this down. at the workplace, they will pay you for work. Keep that in mind. Now, Hannah, if you work harder, they will pay you more. Now, if you get a job that doesn't require a lot of intelligence, they tend not to pay as much. Like, I mean, you can be like a garbage collector, but see, the problem is that a lot of people can do that job, right? So the more people that can do a job, they tend to pay less. Keep that in mind.
People that work in the garbage, they get paid a lot. Nobody wants to do it.
No, they don't get paid millions.
They get.
Okay. You're close. No. Nope. Well, finish and I'll tell you what you're running on. It has 5 around it. So if you look on the periodic table, you're going to see phosphorus right here. So phosphorus looks like this. It has 1, 2, 3, 4, 5 electrons around it. So you got 5 there. Now it's going to gain 3 more. So you're going to put 1, 2, 3. Then put brackets around it, like you see here. And you put 3 negative. Very good. So it has a 3 negative charge. Yes.
The difference is there is no difference except the shape.
Which one is the? It's like group 3, the leg length.
So what's this one? Like the difference?
Could be the hair length.
Wait, so how do you tell those two apart?
Well, it's pretty close. You have to get a ruler maybe. See if there's a small difference between the two. Because the fingers, they have the correct. They all have the same number of fingers. Looks like the hair to me. Length. Last, we're gonna put that on video. Okay. So nice. You'll notice that this is for silicon, the atom. Now when you do these for the ion, you've got to put it in parentheses. So you'll have parentheses. It's going to be Si parentheses 4 plus. Now some people write it plus 4. I like to do 4 positive because that's the charge. If you're looking at money, usually it's like you've lost $4. It's different for the atom. When you lose electrons, what's positive is the protons in the nucleus. Is everybody clear? All right, so silicon can be written really 2 ways. You can also find it gaining electrons. Now, which one would you more likely find it as? Probably this one. But it can do this. It really depends on what. What's going to determine whether it's 4 positive or 4 negative? Anybody know? Raise your hand.
Electron configuration.
No. 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 Starts with the N. No. No. Type of metal. Starts with the N. Type of metal.
Naruto.
Nickel.
No.
Nice guess, Jimmy.
Type of metal.
Novium. I'm just looking at metal to start with.
Non-metal. 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 I got it.
That was me.
That was me.
I'll give it to you.
Non-metal. Very good. Who said that, Ray? All right, Andrew.
It would have been 3 plus.
That's correct.
It would have been 3 plus.
This is strontium as an element. It's going to lose 2 electrons.
So then, if it's 2 plus.
You already have one like it on the board.
Plus 2 plus. Then it would be just by itself.
That's right.
And then you're going to put 2 minus, and then you're going to add.
No, you don't have to do 2 minus.
that's
Metals
right.
typically just
That's
lose
answer.
electrons.
Oh, so you're just showing an example here.
Yeah, this strontium
okay.
can because it's in the middle.
I thought you wanted to show both.
No, it doesn't typically do that. This one, because it's in the middle, can try to get to 8 by losing.
All right, got you. All right.
Makes sense? It'll be all right.
I don't want to get charged.
Because we're at Eastern. We're at Eastern.
George, you need some scissors? They're up there in the box.
Thank you.
Zadie, that looks fantastic. It's just kind of like the odd person out. Odd
Yeah,
alien
they're just
out.
a little weird.
Green
Whoa,
alien.
Zadie, how you so far along?
I like this pattern here.
You're looking good?
Take art class?
No.
I'm feeling like a whole mom. Can you record me?
No. I am recording you.
Oh, I look like a whole mom.
Rosebud, what are you doing? Are you cutting and pasting this?
I'm looking for my paper. I have a quiz paper.
Yes.
Which one looks like?
So we have our example here, atom, cation, where it loses those electrons. And then we have our anion, where it gains those electrons, 2, 4, 6, 8. So it's shown with the 4 minus, because it's gained those, behaving like argon, behaving like neon. So there's a distinguished difference between these two. So you might want to note that on your notes, that when you see a positive, it's going to look like this with no electrons around it. When you see a negative, it's going to look like this. So who can do phosphorus and strontium? Raise your hand. All right, let's go ladies first. Alex. That is correct. Very good. Yes. Now you're going to add those 3 electrons here. Makes sense? Because you're trying to make it behave like a noble gas. To where they have 8 around it, the law of the octaves. It's about balance. So you're going to add those. Right. Make sense? Yeah, now it's balanced. To be a good scientist, you really have to be a good observer. They really go hand in hand. So today we're trying to observe patterns from this alien sheet that we got from the Chemistry Association, American Chemistry Association. So if you can observe patterns really well, that makes you a good scientist. Whether you're going to look at like medicine or veterinarian animals, or if you're going to be a scientist in the molecular world, you're trying to figure out what works. And you can see up here, we're not the ones deciding that 8 is the right number. That's what the atom has decided. And the law of the octaves. Rachel, it's about stability, right? So we're trying to get stable, and so is the atom. The problem might arise if you only see finance as your primary means of stability. It might not necessarily make you happy, right? There are people that go to Wall Street and they'll earn millions of dollars and they'll retire within 3 years, because it's not necessarily something that they're doing that's making them stable. They're just trying to make a lot of money so then they can go and do what they want to do. So that's the hard part of life, is figuring out what is going to make you stable, Noah. What's going to make you the most productive person that you can be. And oftentimes your job won't do that. The average person stays at one job 5 years. That's the average. Basically. Doing the same thing over and over again can become very boring. Yeah. Where's that? Oh, you haven't seen anything yet. We'll just wait till you get a job.
Mr. Shepard, I don't understand what we're supposed to do.
Man, I need to. I swear to God, I Maddie, on
To get an A. Yes, you may. Noah, where's your work?
Oh, it's in my folder.
Is that what you're going to tell your dad when he watches this video? Everybody else is working?
I know his dad.
Josh. So you've got the atom configuration and the ion configuration for the same element, fluorine and fluoride. So this would be the fluorine, this would be the fluoride when it gains that electron, 2p6. So you want to record that when you're dealing with an ion, you're going to have a different configuration. It's trying to get to the noble gas configuration. So 2p6 is going to behave like neon. So if you look on the periodic table, you'll see neon is 2p6. And over here is a shortcut for helium. That's a shortcut for configuration. You can write the noble gas. Then on the back, it's just more of the ion atom. And this is the orbital configuration. The one up, one down, which is what you see right here, the orbital notation diagrams. They're wanting you to do right there. So we'll check this tomorrow. Homework.